Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy them. So check out Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. If you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. Go to dataengineeringpodcast.com/Linode today to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And don't forget to go to dataengineeringpodcast.com/chat to join the community and keep the conversation going. Your host is Tobias Macy, and today I'm interviewing Eric Kansa about Open Context, a platform for publishing, managing, and sharing research data. So Eric, could you start by introducing yourself?
Hi, my name's Eric. I direct the Open Context Project, and it's a nonprofit publishing service for archaeology, archaeological research data. And it is now, started out in 2006. It's gone through several different iterations over the past several years. And we currently have about 1.5 million entities that we've published. We can talk about more what that means later. From roughly about 1,000 different researchers and institutions around the world. And it is really intended to be a way of sharing a lot of the structured data that comes out of the world of archaeological excavations and archaeological surveys.
And do you remember how you first got involved in the area of data management?
Yeah, mostly it was born out of frustration. I was doing my graduate work, my dissertation work in the late 1990s in archaeology. My background was focused on studying the early Bronze Age and the impact of the formation of the Egyptian state and civilization on its neighboring regions. And that work involved building some databases and some GIS. And I was really interested in seeing, how the data that I was creating and exploring and how it would relate to the data that other researchers had also developed. And it was super frustrating because there was really no access to their data. So we would get these very, in some ways, frustratingly superficial publications where they would summarize a few results from excavations that were related to what I was looking at, but I was never able to see the structured databases. What are the actual counts of the different things that they were finding, and how did that relate to what I had? So that was one of the real reasons why I wanted to get into this area, is because there was a real niche there, that there's really a strong need to be able to compare these different data sets and try to see the bigger picture. And decades later, we're still working at it, and it turned out to be a much harder problem than I initially naively thought it would be.
And so along that journey, you ended up working on building the Open Context platform and organization. So can you describe a bit about what it is that you're doing at Open Context and the mission that you're trying to drive towards and how the overall project got started?
Yeah, so we recognized early on that there are conventional modes of publishing in the research world, in academia, were just not sufficient for managing structured data. So conventional articles, books, and reports, those are the sort of bread and butter of scholarly communication between researchers. And that's that world of publish or perish, right? So people are publishing at a feverish pace, but those publications are very difficult to use in any sort of for any sort of quantified analysis, or difficult to aggregate, all sorts of different difficult issues with them in actually reusing the information that they're presenting in these conventional publications. And the other issue is that there's a big issue with archaeology in that it is often relying on destructive methodologies. So when you dig a site, you're actually destroying that site. And in the process of excavation, you have a really strong professional and ethical imperative to do very detailed recording of what it is that you're encountering when you do that excavation. You have to note where you're finding everything. You have to note stratigraphic relationships between different deposits. You have to know where different architectural features are. There's a huge amount of recording that has to take place, and that recording is actually quite complicated. And it's typically done using databases of one form or another to actually record this excavation process. And unless we come up with ways of keeping that information, keeping those records in those databases, then that process of excavation, destroying sites, all the information that comes out of that will be lost unless we do something to preserve and archive and share these digital data. So in addition to, opening up new research opportunities, which is one of the things that got me excited about this issue about, managing data, we have this really important ethical imperative of actually, this is the way that we're going to pass an archaeological record down to future generations if we are successful in the management of this research data. So those are the sort of driving forces behind this. And then open context is our attempt to try to provide, practical real world services in order to try to meet those sort of larger needs of dissemination, opening new research opportunities, and also putting these data into formats, into a larger public context and into digital repositories where they could be preserved.
And so the data sets that you're managing, are they solely dedicated to archaeological research, or do you have other scientific domains represented as well?
The vast majority are archaeological. We have one test data set in public health, but for the most part, we're busy enough with the archaeologists that we're really focused on that need. And the other issue is that our publishing model, the way that we curate the data, really requires some domain expertise. So just because of who we are in terms of our own background and staffing and LVAT, we do focus on archaeology, not other outside domains where there could be also very different kinds of data modeling and metadata and ontology kinds of concerns that beyond our expertise and comfort level.
And in terms of determining which data sets you are willing and able to work with, do you have a particular set of guidelines or protocols for when you're first interacting with somebody who comes to you with a particular set of records that they want to publish on your platform?
Yeah, absolutely. It's important for us that the research that we publish is coming from projects that are meeting the normal standards of professional conduct that are in the discipline of archaeology. And these are professional societies in the field have, ethic codes, professional norms, and there's also laws that govern how archaeology is conducted in different jurisdictions around the world. And so all of those different kinds of standards and norms have to be met for us to engage with the researcher to publish a data set. So this is an important thing because with those sorts of professional conduct frameworks help establish, that we are working for the archaeological research community, and so we don't want to provide a platform for basically for people who are doing treasure hunting. So there's a world out there of people who are doing things like illicit metal detecting and whatnot and treasure hunting that would actually, if we were to publish that kind of information, may endanger sites. They might get vandalized, they might get looted, and we want to make sure that we're not facilitating the destruction of cultural heritage. So this is so working with a professional community of people who agree to a common set of ethics. That's something that is an important aspect of who we work with.
And in terms of the actual data that you receive from these different research projects and archaeological excavations, what sorts of data formats are you dealing with, and some of the unique challenges that come along with the nature of the data that you're dealing with in terms of how it's obtained, how it's recorded, and how it's structured?
So most archaeologists are not necessarily experts in databases, and the domain typically involves a lot of use of pretty normal sort of office suite kind of products. So the more sophisticated archaeologists are using relational databases, databases like FileMaker or Access, especially. A lot of people use Excel for recording structured data, and there's a lot of variability in the kinds of consistency of the data that people record. So some people do have different kinds of protocols in place for data validation so that the data sets are more consistent, and a lot of people don't. And so there's this kind of an issue that some data need a lot of work and after the fact cleanup and that can be pretty labor intensive. One of the other issues is that archaeologists collaborate when they build their data sets typically. So a single excavation may have different individuals who are documenting, describing archaeological contexts, which are different kinds of deposits of dirt that they encounter when they dig. And they would have different specialists who would be studying the different classes of materials. So typically there would be say, animal bones that are recovered from an archaeological site. And those are described by a zooarchaeologist, somebody who has training in zoology and anatomy. There could be seeds, charred seed remains that are being described by a botanist. There could be different experts who will be studying different aspects of material culture. So pottery, coins, stone tools, metal implements. Some other people might be studying different kinds of artwork or sculptures or all sorts of different kinds of materials, sometimes even textiles. So there's a huge number of people with very different kinds of expertise, and they typically create their own data sets. And the main way that these different data sets can be related to one another is through a shared context of where is it that an object or a bone or a seed was found, which archaeological context was the source of that material. And one of the interesting and challenging bits is that because different researchers are basically managing their own data sets individually, bringing them all together can actually be a lot harder than you think it should be, because somebody writes in their Excel spreadsheet that a certain bone comes from locus, which is a common term for an archaeological deposit, locus 10, and they write L.10, and then somebody else in a different database is looking at stone tools from that same locus. They might write locus 10 or just 10. So there's this issue of inconsistent identifiers that are used to reference archaeological context, and that could actually be a very big headache in order to relate these different kinds of materials all together for just one archaeological site. And so this is why there needs to be a lot of investment in trying to go through and understand the different ways that some of these identifiers are expressed and just reconcile them so that you can actually bring the materials together in the way that they should be.
And in the process of onboarding these different data sets from various research activities or dig sites, as you were saying, there's a lot of domain expertise that's required to be able to make an effective use of that source data and convert it into the schema that you've established for open context. So can you talk through some of your strategies and tactics for ensuring that you are able to make an appropriate set of transformations for these different data sets and try to extract patterns to make the process more repeatable, and also any issues that you encounter during that activity as far as mitigating data loss because of those conversion efforts?
Yeah, I mean, on the aspect of data loss, whatever, the open context has a very, very abstracted, generalized global schema. There's not much more to it than sort of almost like a triple store or a key value pair so type of thing describing every entity. And we have some common metadata requirements and some common rules of inference around all that help make things a bit more discoverable. But really, a researcher who submits a data set to us can describe those data with any sorts of attributes that they want. They often have their own control vocabulary. Sometimes they're going to be referencing a shared control vocabulary that might be professionally curated. So, especially the people working with animal bones, pretty much they're classifying the species, the biological taxa of the bone in very similar kinds of ways. And so that becomes an easier issue in terms of sharing, linking across different classification systems. But for the most part, people come up with their own idiosyncratic ways of describing stuff. And open context's main assumption is that stuff is related via contextual relationships, that a certain record will have relationships to other records that we can describe. So a lot of we're very sort of flexible, I guess, in terms of the different kinds of schemas that we accept in terms of especially with descriptive attributes. The hard thing really centers in making sure that we're understanding the identifiers correctly in the source data set. So context identifiers are the thing that we focus a lot of attention on. And the other thing is just, what is it that is being described is one of the things that we would care a lot about. So sometimes, depending on the way that somebody structures a data set, there could be multiple records. Say if they're just using a flat table like an Excel spreadsheet, multiple records are describing the same thing. It's just that they want to add multiple attributes to that one thing. So like a coin might have multiple motifs that are on it, and they would have multiple rows in a spreadsheet to add that there's multiple motifs on a certain coin or a certain potsherd or whatever. And we need to understand that, okay, this is the same coin, it just has multiple attributes. It's not a mistake that this thing is repeated over and over again. So that's so there are those are the sorts of questions that we have to look at when we look at mapping the schemas from a source data set and going through our extract, transform, load process and moving things into open context. Yeah, essentially it's just that, we have to understand what is being described, and, are they being described by attributes that could take on multiple values or not? And then what are the relationships between the things that are being described?
And for the data that ends up in the open context system, you encourage the use of Creative Commons licensing. So I'm wondering if you've had any issues in terms of needing to educate researchers as far as the implications of that licensing, or if you've had any pushback from people who initially approach you once you mention those licensing requirements, and just your overall considerations of using Creative Commons as the license category for the data that you are hosting on your platform.
Yeah, I mean, the whole issue of intellectual property in this space is a huge area of research, and it touches on a bunch of different considerations. So there's a sort of practical interoperability consideration that, if we all use common standard licenses, then the content that we have would be legally interoperable, and which is nice, and that's one of the sort of wonderful things about Creative Commons. It's a standard licenses, you can have interoperability, and it's all expressed with standard metadata too, so that, in a machine readable way, you can know what the copyright status is of some content. So that's great. But one of the big complications is that, it's not just interoperability that we need to optimize, especially in a field like archaeology. But in archaeology, we're dealing with lots of different communities around the world with different sets of values and different assumptions about what the archaeological past means to them and who owns that archaeological past, who can speak for it. And those kinds of concerns mean that the ethical landscape around using Creative Commons licenses is a lot more complicated. And so we actually say in open context, open access, open licensing, these are wonderful and powerful tools, but they're not universally appropriate. And so there are definitely going to be circumstances where open context is not a good platform for sharing data. And so if the data have specific kinds of sensitivities, especially say if there's indigenous people who regard this information as important for their own heritage, especially in situations where there's maybe a history of colonialism, then you have to be very careful about license choices and whether or not a platform like Open Context is an appropriate way of disseminating the data. You might have to find some more restrictive mechanisms in order to take a sort of more judicious and sort of situationally aware approach about all that. So it's an interesting kind of an issue. One of the other issues about copyright licenses, like with Creative Commons, is that they're copyright licenses, and in the United States, there's this distinction between facts and expressions. So factual data, kinds of things like measurements of, the height of Mount Everest or something like that. Factual data is typically not seen as something that copyright actually covers. So there's a sort of an ambiguity also about what aspects of a data set are expressive and that are sort of the domain of copyright, and what aspects of an archaeological data set are more factual, where copyright probably doesn't apply anyway. And so no matter what license you apply to it, the copyright is probably not legally applicable anyway. So those are the kinds of issues that we have to sort of walk through with the researcher community, and also essentially the professional community, to try to deal with some of these questions, because we want to make sure that we're trying to use these tools like interoperability, license interoperability, open data. We want to have that to lead to good outcomes and not harmful outcomes. And so that's why we want people to be thoughtful about how they're applying these kinds of tools.
And further along the topic of expressiveness versus just factual information is any research articles that might either accompany or reference the data that is stored in open context or that's being submitted to open context. So I'm wondering, in terms of the metadata that you track for a given data set, if there is any either reference or content of any research articles that might be associated with those data sets, and how any sort of industry journals or publications for archaeology, any relationship that you might have with them, whether it's positive or ambivalence.
Yeah, actually, it's mostly been very positive in terms of the conventional publishers that we work with. And there's a couple different issues. One is that citation is the main kind of currency in academic research and promotion, tenure, that type of thing. So that we definitely want people to cite data sets, because people put a lot of work in creating those data sets, and then they put a lot of work in annotating, describing, and we put a lot of work working with researchers and cleaning them up and making them hopefully more usable by publishing them with open context. So that effort we want to recognize and reward, because it helps motivate people to do the right thing in sharing data. And if people get citations and people cite published data sets, then that should start nice positive feedback loop of people getting that kind of recognition. And then, and the ideal scenario is that researchers will do well by doing right. That by sharing data, then they will advance their own careers. So in that sense, we participate in a variety of mechanisms in order to try to make citation easier and more meaningful. We Open Context uses a service called EasyID, which is hosted by the California Digital Library. The California Digital Library is the main sort of institutional digital service, institutional repository for the University of California system. So all the different campuses of the UC system are involved with it. And EasyID is a service to mint persistent identifiers. And in our case, the persistent identifiers that we mint with EasyID we use DOIs for large aggregations of data. In open context, those are called projects. We also use DOIs to identify tables, so another large aggregation of data, which would like a table that would be a CSV dump of maybe thousands of records that we would express. And then we also use something called ARKs, which are called archival resource keys. And that's another persistent identifier. And we use that for more granular kinds of content in order to facilitate citation of something maybe very specific. And this is one of the advantages of open context versus sort of more conventional data repository, is that we can make very specific entities of interest to an archaeologist directly citable. So say an example could be a coin. So somebody might discover a coin, it might have some interesting, it might be minted maybe in Rome and discovered clear across the empire all the way over in Turkey. And that would be kind of interesting to be able to trace, wow, that really traveled far in antiquity. And you might want to reference that specific object, that coin. If we only published or only curated data sets as they sort of came to us, and big tables of spreadsheets and big relational databases, that coin would not be something that you could actually cite, because it would be a record that might be in a giant data table, or it actually might be information that might be scattered on several different data tables, right? So one Excel spreadsheet might describe the coin as described by the numismatist. Another relational database might describe a coin that was that as it was recovered by somebody creating an object inventory. And another relational database might describe the contextual relationship, the context where that coin was actually discovered. And when we publish things with open context, we're bringing all of that information from all those different source data files together to create a more cohesive picture of what the excavation results are. And that means that that information about that one entity, that one coin, pulling that information out from several different sources and actually making it very convenient to be able to cite and discuss in publications. And that's one of the sort of reasons why a lot of researchers find our approach actually kind of interesting, and is that, yeah, they want to be able to talk about a coin. They don't necessarily only want to cite a spreadsheet, right? That could have thousands of other things in it too. So that's one of the key aspects of all of this, is that it's not just a sort of fitting into the academic cycle of rewards of the citation, attribution is how you advance your career, but citation is actually a really important aspect where people make sense of things. You want to be able to talk about a specific object or context or site, some other entity of interest, and in order to talk about it, you have to be able to point to it, you have to reference it, and citation plays an important aspect in that as well.
And in terms of the technical architecture that underpins the open context platform and the ability to manage these entity aggregations and expose the data for these direct citations and for being able to discover interrelations between the data, can you just discuss the overall technical platform that you've built and some of the challenges and architectural evolutions that have occurred along the
Yeah.
way?
Well, currently, well, first of all, the entire stack, everything that we use is fully open source. And current iteration of Open Context is it's a Python 3 application using the Django framework. And we have a Postgres relational database as our primary data store in the backend. And we use an Apache Solr index. It's basically a big document NoSQL database for things like faceted search. And not a lot of open context is really meant for sort of itself for data analysis or visualization. What we're trying mainly to do is to make the data that we curate browsable, discoverable. You can actually look at it, and hopefully it's somewhat aesthetically pleasing at least. What that also matters because it's publishing, and there's the aesthetic element is an issue. And then once it's browsable and discoverable and all that, we want to try to make it relatively easy to be able to grab the data that you want, and then you can use your own tools that you're comfortable with to actually do your own analyses and visualization. So mostly for the community of people that we serve, that would be like browsing around, seeing, here's a set of pottery from this one archaeological site, and then you narrow it down. Okay, so I'm just selecting the certain time period of my interest, and then you can just export a CSV table of that and then walk away and play with it in Excel, something like that. More sophisticated users can use our API to do more sophisticated kinds of things with it. The API that we provide provides most all of the data in GeoJSON, which is a very popular geospatial data format. And you could also usually interpret the data that we have as JSON LD and then have that converted into a graph of RDF triples. So there's different options for using it, but basically we're mainly aiming to try to make the data easier to discover so that you can grab and use in the tools that you're interested in. When we initially started, we were working at PHP and had a MySQL background, backend, and I guess I started working in Python probably 2013. It's when we made the switch, 2013, 2014.
And in the process of that switch going from MySQL to Postgres and PHP to Django, was there a high level of difficulty in terms of being able to translate the data that you had present on the platform at the time to the new system? Or was it a fairly clean mapping where, because it was simply just different relational databases, you were able to largely do an export and restore just as a set of SQL statements?
Yeah, actually, weirdly, we went through XML as an intermediary. So the PHP MySQL version of Open Context, instead of having mainly a sort of GeoJSON structured data format that you could use as a view for all the different items, it was a XML structured data format. And this goes back to some of the sort of intellectual pedigree of Open Context. There's a system at the University of Chicago called OCHR, Online Cultural Heritage Research Environment. And the initial incarnation of OCHR was, I mean, it still is an XML database, a native XML database. And they had a schema that they did publicized called ArchaeoML, the archaeological markup language. Essentially using ArchaeoML as our main kind of schema in our own backend, a simplified set of the ArchaeoML schema, actually. And so when we did the export from migration from the PHP MySQL system into our current iteration, it was using those XML documents as the source data.
And as far as the ontology that you maintain and the taxonomical details of the data sets, is there a lot of difficulty as far as being able to map the different entities to those sets of attributes in order to make them more easily linkable so that you can traverse any relations between them? And then in terms of the metadata, I'm curious if you track the dig or the specific research project that the different entities are derived from so that you can have sort of a meta level of linkage, so where you track the different digs in relation to each other and then from there dig into the separate entities that are discovered.
Yeah. So every single project, as I mentioned, has and even within a project, there'd be a lot of diversity. Different researchers who are working on different kinds of classes of materials. So, like the pottery specialist, the bone specialist, the stone tool specialist, would come up with their own set of descriptive attributes to describe the materials that they're looking at, and they could have their own control vocabularies. And in archaeology, those are called typologies, usually sets of measurements that they're interested in, et cetera, et cetera, et cetera. And that is, unfortunately, the sort of state of discipline is that there's not a huge amount of consensus between researchers describing similar kinds of stuff. So that diversity is one of the reasons why we have the architecture that we have, and then in that we have to publish the ways in which archaeologists are describing their materials. We have to publish all of these different kinds of attributes as data also. And that's part of the sort of intellectual contribution that these researchers are creating, because, they're usually encountering stuff that very few other people have encountered, and they are making it up as they go along. This is an active area of research where people are trying to find new and better ways of describing archaeological deposits or archaeological material culture, that sort of thing. So this is like, they have a lot of intellectual investment basically in creating and defining their own descriptive attributes. So when we publish data sets, we're also publishing a custom set of attributes associated with those data sets. And in order to achieve some interoperability, where we can, we use the SKOS, a simple knowledge organization system, to say that, this one term in this one researcher's data set, let's say control vocabulary term, might be a close match to this concept in the Getty Art and Architecture thesaurus. And so that would be a common standard that would be widely applicable in cultural heritage. So a good example might be a type of Etruscan pottery called bucero. So the bucero is this really pretty sort of dark gray, shiny, heavily burnished kind of pottery. And it might be described in a couple different ways in different researchers' data sets, but there are some museums and the Getty Art and Architecture Thesaurus that have their own control vocabulary that describe that. And Getty Art and Architecture Thesaurus is a nice openly licensed linked data kind of thesaurus. And we can say, this term Bucaro is a close match for what Getty said, how Getty defines it as Bucaro. And then we could essentially make those common linkages across these idiosyncratic kinds of descriptions to point to some common standards. And so that is more or less the sort of level of semantic interoperability, I guess, that you would get in open context, where we basically start drawing relationships between different vocabulary terms. So it's not that sophisticated. We're not in the sort of business of supporting sort of inferences on owl ontologies or anything like that. That would be an awesome thing to do more in the future, especially if we get to collaborate with some people with those sorts of interests and expertise. But we do get is the ability to combine different data sets, and we've been most successful with zooarchaeology, with animal bones, where people have we've basically using that kind of technique. You can actually do searches now and discover all the cattle bones and all the tibia of cattle from dozens of different archaeological projects, and that is a pretty big accomplishment in a field like archaeology where everybody's doing their own thing.
And once the data is written into open context, is it largely static at that point, or do you have people who will periodically go back through and add additional information or metadata or linkages after the fact? And is that something that users of the platform are able to contribute as suggestions or enhancements to different data sets?
That would be really interesting to be able to support that. No, we haven't built out that sort of functionality of sort of user contributed semantic enhancement, or even just hey, there's a bug here, an error. One of the things that we've been experimenting with and are going to be moving ahead with in the near term is also just version control of data. For the most part, most of the data that we publish with open context is, once it's published, is pretty static. The main changes are usually going to be additions, where we might publish a set of contexts first, and then the pottery person is ready with their pottery data, and we add to that context data set pottery, and et cetera, et cetera. So most of it's additions, but sometimes there's going to be error corrections and that type of thing. And we have, essentially, because we generate all these JSON LD documents, we have used Git actually as a version control mechanism for all of that. We're doing more of that internally because it was starting to get unwieldy with Git. We were building these giant bloated Git repositories that were getting too difficult and just crashing my machine all the time. So we're using Django reversion for tracking changes internally, and we're trying to figure out a good way of expressing that publicly, what those changes are. So that's actually an area of active development, but we do have a sort of an audit trail of how things are changing internally.
And that brings me into a couple of my next questions, one of which is the average size of the typical data set that you would be processing, just in terms of relative volumes. Are they generally in the megabyte, gigabyte, terabyte scale? And then I know that part of your overall endeavor is also to serve as an archive repository for a lot of this information. So I'd be interested in exploring some of the complications that arise from trying to maintain a long-term record of this information, particularly as storage formats and physical medium changes over time.
Well, I'll just start with the archival issue first. We're not a preservation repository because that involves a whole host of institutional requirements and workflows and processes that we just don't have the capability, we don't have the scale to be able to achieve ourselves. But what we do is when we publish data, we put the data that we publish into preservation repositories. So, but those are managed by other institutions. So historically, the main institution that we've worked with and we continue to work with is the California Digital Library, which is, again, the main repository of the University of California system. We're also using Zenodo which is another repository that's it's at CERN, the particle physics research lab in Switzerland. And the rationale for using Zenodo is that they have a very nice, convenient API, and they support a lot of metadata using linked data entities that I find useful. And there's already a lot of sort of convergence on using them by other archaeologists. So it's the material is there with there's a good sort of a community of people already engaged with Zenodo. So that's for long-term data preservation. We don't actually, we're not going to be the end place for it. But what we can do on our end is to try to make that data preservation more feasible, more likely to actually work out, in the sense that by publishing data with open context, then we're extracting data from a bunch of different source data sets with very different kinds of file formats and whatnot, and expressing it as structured data in JSON LD for the most part, CSV. So these nice simple text formats that lend themselves to preservation. And then the other thing is that oftentimes we often get a lot of media associated with the structured data that we publish. So, talking about coins or pots or whatever, one of the nice things is about having that sort of level of granularity and citation that we have is that we could also do things like relate specific pictures to specific objects, or specific pictures or even 3D models to objects or in context. And we do that also. And when we publish the material in open context, we're also depositing a lot of media files, binary media files of one form or another, into digital repositories also. So those are the ways in which we work for archival, in the archival sense, and providing standard metadata and everything that hopefully makes the job of the digital archives easier in order to maintain the data. Right. So, I mean, it varies all over the place. So some data sets are quite small, say a megabyte spreadsheet or something like that, and then they go up from there. What really bloats size or expands size greatly is if somebody has a lot of images or other digital media. So 3D files take up a lot of space, obviously, but in certain circumstances, we recently published a set of some archival materials for the describing the Great Sphinx at Giza in Egypt, and even one file, one scanned image could be a gigabyte itself. So and and we would have something like 30,000. So that there's sometimes some large space and storage concerns, and again, um, we really couldn't do what we do without having that fundamental infrastructure, the services being provided by the digital repositories, the digital libraries, hosting all these things over the long term, because hosting all these things on our own actually starts getting expensive too, with all those files.
And as you mentioned, you don't do any in-house complicated analyses or visualizations of the data that you are hosting. So I'm wondering what some of the most interesting or unexpected uses of your data you have seen out in the wild.
Yeah, probably the most significant use of data for us has been the Digital Index of North American Archaeology, and it's the DINA project, is this acronym. So what DINA is a aggregation of data that's a little bit different for us in open context. Is that most of the data in open context come to us from academic researchers. DINA, the data sets coming to us in that project are coming to us from state government officials. And so in the United States, there are historical preservation laws that are at the federal level, and the federal government has delegated the enforcement of those laws to different state governments. And so each state has officials in charge of managing cultural properties, historical resources within the state borders. And each state develops information systems, so databases basically, to help in that administration. And you can imagine there are about 50 different schemas, data sets, 50 different ways that states have sort of tried to figure out how to manage historical and archaeological sites. And what's interesting about that is that the state governments have the best window onto the sort of what is known about the past in terms of what is known about the settlement history of the North American continent since the Pleistocene, because the states have aggregate all of this data that is being required by law to be able to create. And what's the neat thing about DINA is that we're gathering by bringing these data sets together from several different states. For the first time, researchers are able to see a much bigger picture about what human settlement is like across the North American context over very deep, long periods of time. So you can see what things looked like 10,000 years ago in terms of what's known about where there are archaeological sites, and compare that to what the situation was like 500 years ago, at the beginning of European colonization. So that is a really powerful kind of a resource. There's all sorts of different kinds of really interesting issues in terms of like these data sets are also not created with any sort of systematic sampling at all. There's all sorts of biases in them, and that's something that I think is a really fascinating area to explore, and it's going to be a huge challenge for interpretation. But nevertheless, this data set is it's sort of as big as it gets in archaeology for looking at big picture kinds of questions. And the big research outcome actually hasn't focused on so much of like where people are living in the past, but the big research outcome we've had with the DINA data set has been modeling what's going to happen to these sites in the future. And we have most of the coverage of DINA focuses on the American Midwest and the Southeast, but we have a lot of the Gulf Coast and the Atlantic Seaboard in the DINA data set. And this paper that was published in PLOS One described what the impact would be with, say, a 1 meter, 2 meter, 3 meter rise in sea level driven by climate change. And just with a very modest 1 meter rise in sea level, which a lot of projections are saying is going to be happening within next few decades, where you're going to lose 13,000 known archaeological sites. And that had a huge amount of press coverage and media impact because a lot of people didn't even know that there were 13,000 archaeological sites in North America, let alone just along the coast that we'd be losing to sea level rise. So that one was that made a big impact, pardon the pun, it made a big splash. And it was recently cited in the 2018 National Climate Assessment, which was a major US government report about the challenges of climate change. So that's probably one of the key research outcomes that we've had with open context. And then there have been several smaller but still interesting and significant ones. Again, with the zooarchaeological data, people be able to see patterns in the way that animal domestication, which happened first in the Near East, in places like Iraq and Syria and Southeast Turkey, and how those domestic animals and the economies around animal husbandry spread towards Europe. That's something that was facilitated with open context, and there've been publication with that, and then the data that we published originally with that has been reused in other publications, which is also interesting. So there's actually reuse of these published data for more than one research purpose. And then there's other applications which are kind of more fun. People using the API to do things like pull in the data for virtual reality or for augmented reality kinds of applications. Those are smaller scale, but what's fun about that and what's also useful about that is that we really need to build up the technical skills in archaeology, people who have the data skills to be able to engage with a system like open context and develop the sort of understanding about how to use a web API and what can you do with it. And so those are the types of things that are maybe in the longer term really important, because that starts getting people more engaged with this whole idea of why shared data is important, and what can you do with APIs. Oh, whether it's an open context API, oh look, there's data from a completely different source. Maybe you combine it with geonames or combine it with some other wiki data or something else, and then that starts to maybe enable some really interesting kinds of applications.
And in the process of building and maintaining the open context platform and working with researchers and archaeologists, what have been some of the most interesting or useful or challenging lessons that you've learned?
One of the biggest things is that it is incredibly slow to change a disciplinary culture, and that is that most academic researchers are in the world of publish or perish, and so they have a lot of professional pressures to make publications that they're sure that their peers will recognize as something as valuable. And so that sometimes leads to some risk aversion. Like publishing data is something that's relatively new and it's not a sort of tried and true path to tenure. And so that's one of the reasons why its adoption has not been as fast as we would want. Fortunately, that situation is changing now that we're starting to see some interesting reuses of data and people are starting to cite it and it's appearing in bibliographies of research papers and whatnot. So things are definitely getting better, but it has taken more than 10 years to get to this point, and you would think that that would be something that would have been more of a no-brainer. Other issues that are also really fascinating is just that again, that what gets people excited is there are a bunch of things that get people excited. So some research really likes seeing their data online. They want to show it off. They want to see. It's a great way to have sort of an exhibition. So there are museums and other institutions have beautiful websites that show off their collections, and researchers are happy to use a service like Open Context sometimes so they can participate in that, show off, what is it that they've discovered, and also show off in a lot of ways that, look, I do such really awesome and rigorous recording. Look at all this wonderful data that I've got. So that's a positive incentive, and so that's something that I think has been underappreciated in the world of research data management. And that a lot of times there's this sort of discussion of carrots and sticks about this, and there's sort of efforts to make sharing data mandatory, and that if you want a grant, you have to share your data. And in a lot of ways, I think that's I'm very sympathetic to that. I think that's definitely the right thing to do. But we also need the positive incentive. So citation is obviously a positive incentive. People coming up with good research outcomes from shared data, that's a good positive incentive. But the other side is just that we want people to feel that publishing and sharing data is something that's recognized, rewarding. It helps make their data look more attractive, it's more usable, their own data set is more usable to them. There's a lot of positive incentives that I think is good that we try to emphasize with open context, because then we want to try to get past the sort of notion that data sharing is this like minimal checkbox compliance thing, where I threw a couple ugly spreadsheets into a repository and I'm done, right? That's not very meaningful. The data are probably not that useful if they're just left as is in Excel with different kinds of color codes and random typos and all sorts of problems in them. It's a lot better if people put in that sort of investment and that intellectual investment in actually trying to understand how to make their data usable and intelligible by a wider community. And that's where I think the things needs to be much more emphasis on that. And that's where I think it's why this field is actually really interesting, is that it's hard to communicate meaning with structured data, and especially in a field like this where we have practitioners who are working on very particular kinds of things. There's not a tradition of this already established, and we're trying to build that tradition kind of from scratch.
And what do you have in mind as far as future improvements or feature additions or overall goals for the future of open context?
Well, I mean, one of the big things right now is that we're really excited because we're working with another developer who's deep in the guts of the system right now, Raymond Yee. And Raymond has a great background in research computing. He's worked with Ungluit. He's done some really wonderful work, and he's a fantastic Python developer. And so one of the first things that we're working on is making it easier to deploy open context, actually, so that sort of much more of a sort of a one-line command line argument type of a thing where you just can set the whole thing up. So using technologies like Ansible and Docker to be able to do that, where you can get an instance going, maybe with some data, and work with it on your own, play with it, and hopefully that'll encourage maybe more experimentation and maybe even more people contributing to this to the open source project, which would be cool. So there's that. Then we have a lot of needs in terms of we're bumping up into some scaling issues. Things are starting to slow down as our index has grown, and so just sharding it is going to be an important next step. Lots of optimization side things to do in the back end to try to improve speed. And once we've got some of that worked out, then we're going to be in a much better position to start tackling some really challenging user experience kinds of issues. So one of the hard things about archaeology and especially the approach that we have is that because there's so many different ways of describing these materials, then presenting search results and making information easy to retrieve and find is hard. And so we need to put a lot more investment in the trying to make the exploration of open context much easier than it is right now, because it is challenging because of the diversity of the materials in there. We need to come up with better ways of guiding users to be able to find what they're looking for. And then making sure that once they found what they're looking for, making sure that they can leave with the data set that they expect it to have in a format that is going to be useful for them without too many technical hurdles in the way.
And are there any other aspects of open context or research data curation and publication that we didn't discuss yet that you'd like to cover before we close out the show?
Well, I think that again, one of the weird things about this, and the harder aspects of this too, is that this is a really new area of research in a lot of ways, and what it really requires are people with the sort of technical programming kinds of skills, data skills, so the sort of data science, I guess, and also library skills, thinking about issues of metadata or preservation, copyright, and intellectual property. And then there's the domain skills, understanding the domain of archaeology and its specific requirements, and why is it that we have 100 different researchers and 200 different classification systems for the same set of materials. So so there's a lot of these kinds of areas of expertise that we have to bring together, and we don't really have right now institutions that are well set up to be able to cope with these new needs. And we don't really have really good, clear career paths and ways of sustaining all of this. And so that's one of the big challenges, that things are very siloed in universities, where say a university librarian does library things, academic researchers publish in conventional journals. We're asking people to come together and bridge several different kinds of domains that traditionally haven't really worked closely together, and that's a real challenge. And that's something that is not just in archaeology, but it's one of the real fundamental challenges of managing research data across all sorts of different disciplines. So we definitely need institutional structures that can help organize that, facilitate that, sustain that, and also the people that are involved in that. There's a lot of expertise that has to go into this that doesn't really fit well within conventional structures. So, the big challenge moving forward is that I think a lot of people realize and that research data is important, that we have to curate it well. We want to preserve it so that it can be accessible for people in the future. People can say new things with it. So there's all sorts of interest in this, but we still haven't nailed down exactly how institutions are going to make this information broadly accessible and usable for the future. Right now, it feels still pretty rickety in terms of the sort of sustaining supports. Like, we want to make sure that this type of thing becomes less weird and much more of a regular part of the way research is conducted in the 21st century.
All right. Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Oh, all right. Well, I mean, that's a really good question. From our own specific work, we spend a huge amount of time cleaning up data sets. We use Open Refine um, a lot, and we spend more time with using Open Refine than actually munging data within Open Context itself. I think so much of it is that so many of the problems that we encounter work well with Open Refine, but there's still that 20% where essentially you have to write custom scripts, a little Python, to be able to munge data in a certain way. And where I think that one of the challenges around all that is, those custom scripts we have checked into the source control and everything, but I want to have that as something that it's a lot more reproducible, and something that and people have been working on this with the whole area of reproducible research. There's been a lot of work, interesting work, using things like Jupyter notebooks and all that type of thing. But it needs to be it'd be really good to be able to have these kinds of pre-processing, data processing kinds of pipelines much easier to curate, and to be able to sort of, I guess, audit, to be able to see exactly what the inputs are, what you did, and what the outputs came out to be, so that you can make sure that if you have a problem, you can trace it and you can justify what you did along every step of the way, and do that in a way that is not overly onerous in terms of, you also have to get stuff done, right? So there's this balance between trying to document everything, be reproducible, and also trying to actually make sure that you can make a deadline, get the data actually out without expending too much time and resources in doing that. So I think that that's an interesting area that could use some tooling. I think it's a really challenging area, but it's something that I'm really interested in. If anybody has any suggestions too.
Well, I want to thank you very much for taking the time today to join me and discuss the work that you're doing at Open Context. It's definitely a very interesting project, and it's filling a very useful and necessary need. So thank you for all of your work on that and for taking the time tonight, and I hope you enjoy the rest of your evening.
All right, thanks, Tobias.